Good morning. This is Henry from ASM Tutoring again with another quick math lesson for you. Today we'll discuss an example of how to graph a rational function. That is a function that is a ratio of two different polynomials. You can see the fraction here. So this is a graph of the function f of x equals the quantity 3x squared minus 3x plus 2, all divided by x minus 1. Of course, it's very easy to graph this on decimals just by putting the function in. But what if we didn't have a graphing calculator available? How would we graph this function? Well, let's take a look. So first of all, you can notice that there's a vertical asymptote. Where does that occur? Well, that occurs when the denominator equals 0, because you are never allowed with fractions to have a 0 denominator. So let's look at the denominator x minus 1. If we start off with x minus 1 equals 0, we can solve this equation by adding 1 to both sides. These cancel out, and we have a solution x equals to 1. So looking at the original graph again, if we add the line, the vertical line x equals 1, we can see that line is in fact a vertical asymptote for this graph of the curve of the original f of x. The red curve will never touch or cross the blue line that is the vertical asymptote. It looks like that right now because the size of a pixel on the screen is finite. But if we zoom in closely, you can see that the red curve will approach, but it will never touch or cross the blue line, the vertical asymptote, at x equal to 1, whether in the lower half or in the upper half. The red line gets closer and closer and closer to the blue line, but it will never touch or cross the blue line, the vertical asymptote, at x equal to 1. Okay. So we have a vertical asymptote, but that doesn't tell the full story, because we can see along this line here and along this line here, there appears to be a slant asymptote as well. How can we solve for the slant asymptote? Well, let's go back to our whiteboard here. If we take the original function, 3x squared minus 3x plus 2, and solve by polynomial division, we can get the slant asymptote without too much difficulty. So we're dividing by the denominator. Remember, denominator, divide, they're both d's. X minus 1. What quantity times x would give us a 3x squared? Well, that's just 3x. Multiplying that out gives us 3x squared minus 3x. Then we subtract this entire quantity, just like long division. We get a 0. What times x minus 1 would give us a 0? Well, that would just be, oh sorry, we have a plus here. That would just be 0. So we add a 0 here. And then we subtract 0, so nothing changes. We have a final remainder of 2, so we have a final term of 2 over x minus 1. Now, to find the asymptote, we want to find out what happens as x gets infinitely large. So we can use a limit to find that. So let me erase some of this stuff down here first of all, so we have room to work. If we take the limit as x approaches infinity of 3x plus 2 over x minus 1. As x gets larger and larger, this denominator here gets larger. But remember, when you divide by a larger denominator, the quotient, the overall fraction, gets smaller and smaller, which means as x approaches infinity, this quantity approaches 0. And we have a slant asymptote at y equals 3x. Remember from your basic graphing techniques, y equals mx plus b, where m is a slope, b is a y-intercept. This is a diagonal line, a straight line, with a slope of 3 passing through the origin, 0, 0. So let's test that against our graph. We'll put in the line y equals 3x. And we can see that this in fact looks like a slant asymptote. The red line, the red curve, will approach this black diagonal line, but it will never touch or cross it. If we zoom in, we can once again see the red curve is approaching, but it will never touch or cross the black line, the slant asymptote. And we can verify this in the lower half as well. Again, the red curve approaches, it will get very close to, but it will never touch or cross the black diagonal line, the slant asymptote. So we have our asymptotes. The only thing remaining is to try a few points. Well, if x is greater than 1, for example, if x is 2, 3 times 2 squared minus 3 times 2 plus 2. All we have to know is that positive or negative. Well, 3x squared is going to be greater than 3x for a whole number, and plus 2, so that's obviously going to be positive. 2 minus 1 is also positive. A positive divided by a positive is a positive. So when x is greater than 1, f of x must be in the positive realm, which is what we see here. What about when x is less than 1? Let's pick a number -3. So -3 squared is still positive, so that's 3 times a large positive minus 3 times -3, which is also a positive quantity because negative times a negative is positive, plus 2 more, that's still positive. So the entire numerator is positive even when x is less than 1. But when x is less than 1, the denominator becomes negative. A positive numerator divided by a negative denominator will give you a negative. So that tells us that in the region where x is less than 1, f of x is going to be negative, below the x-axis. And that fits this curve that Desmos graphed for us. So that is enough information, the asymptotes and the knowing the regions where the graph will be positive versus negative, that will tell us how to graph this function. You could be more detailed, pick a few specific points and plot them on the curve. You could do that. But for a rough sketch, knowing the asymptotes and knowing where the curve is positive or negative is generally enough to draw a rough graph of the function. So this has been a simple example of how to graph a rational function. I hope you found it useful. If you'd like to learn more, I'm available for hire as a private tutor. You can look up my website, a-stem-tutoring.com, or you can send me an email. The first 1-hour lesson is free for all new students. Try before you buy. You take no risk. The burden of proof is entirely on me to demonstrate outstanding value in helping you succeed. And as a thank you for watching to the end of today's video, if you mention the code FREEBOOK when you contact me, at our first tutoring session, I will give you a free copy of my book, Smart Suggestions for Student Success. I wrote that book in an effort to help students, and especially high school and college students, to succeed in school, in work, and in life. Thank you for watching. Bye-bye.